Hello, I am Dr. Ajay Sharma, Department of Electronics and Communication Engineering, GIMS Engineering Management Technical Campus, Knowledge Park 3rd, Greater Noida. The subject that I teach in this semester is digital communication. This subject is for BTech 5th semester students, and this is the main subject, and the topic that I discussed in this video lecture is inter-symbol interference. In short, we can say ISI, inter-symbol interference, and I pattern. Both are correlated to each other, inter-symbol interference and I pattern. So we start with what is ISI? What is inter-symbol interference? Actually, this is the form of distortion of a signal, right? So ISI sometimes be the main cause of distortion in a signal. So ISI is a form of distortion of a signal. Sometimes signal is distorted by inter-symbol interference effect, in which one or more symbols interfere with subsequent signals. In which one or more signals interfere with subsequent signals. You know, when you send in digital communication, when you want to send the data which is in digital form, 10 form, with the help of a line coder, you convert this 10 in a digital symbols. Digital symbols are nothing but these are some voltage levels that represent 1 and 0. So each symbol like the same way in digits, if you have a bits 1 and 0 is a digital data, 1 and 0 has its own bit period. In the similar way, when you convert 1 0 in a symbol also has its own symbol period. So what you have to do in digital communication, you have to convert a 1 0 string in a string of symbols, right? So sometimes what's happened as the signal, so the output of the transmitter is a series of symbols, and these series of symbols, propagate through a channel. So as the signal progresses, these symbols are broadened, sometimes spread, sometimes means each symbol has its own time period, own time limit, own symbol period. But what's happened, sometimes symbol, whatsoever interfere with the neighbor symbols. It means some part of the symbol reach to the neighbor or subsequent symbols and interfere the neighbor symbols. This is called inter-symbol interference. Each symbol interfere with neighbor symbols or subsequent symbol, right? And this is a inter-symbol interference, and that makes the signal distorted. So distortion come in the signal with ISI by symbol interference. Subsequent symbol or neighbor symbol sometime cause inter-symbol interference that cause noise or delivering a poor output. All right. So this is inter-symbol interference when symbol, cross its boundary to reach to the subsequent or next symbol, cause next symbol. So this or you may say some part of the symbol reach to the neighbor symbol and create inter-symbol interference. And when this type of signal reach to the receiver, and when inter-symbol interference is very much high, then receiver is confused to detect 1 and 0 in a right way, and that creates a noise also, right? So the chances of noise in the receiver is that when 1 was sent by the transmitter and receiver declares 0, when 0 was sent by the transmitter and receiver declared as 1. So this is the case of error that come in the picture as far as digital communication is concerned. Hello. Sorry, there is some net issue. That's why it's a disconnection. The net is disconnect, and sorry for the interruption. Now we move forward. Now, what are the causes of inter-symbol interference? The main cause of inter-symbol interference are, there are two causes. One, multipath propagation. Second, non-linear frequency in channel. So these are the two factors that creates problem. So the ISI, inter-symbol interference, is unwanted and should be completely eliminated to get a clean output. That all we want. We have to minimize this ISI effect so that we can minimize the error at the receiver. So the cause of ISI should also be resolved in order to less its effect that we want to do. So while designing the transmitter or receiver, it is important that you minimize the effect of ISI so as to receive the output with the least possible error rate. Means receiver declare 1 and 0 in a right way. And this is only be possible when you eliminate the effect or minimize the effect of ISI, which you called as inter-symbol interference. Come to the I pattern. What is this I patterns? A effective way to study the effect of ISI is the I pattern. If you want to study the effect of ISI when the signal reaches to the receiver, and if you see how much the signal is affected by this ISI, then I pattern is the easiest way. By seeing the I pattern, you can now guess how much the ISI affect the signal, and you can then take some steps to minimize the effect. So the name I pattern was given from its resemblance to the human eye for binary wave. So when you send a binary wave or binary signals, and these binary wave or binary signals when reach to the receiver form a pattern, and the pattern is look like a human eye. That's why the name is given to this is as eye pattern, because the pattern is look like a eye. So the interior region of the eye pattern is called eye opening. The following figure shows the image of an eye pattern. This is, for example, if you see this figure, each part of this particular eye pattern has its own meaning. For example, if you focus on that, this is the width, this is amount of distortion set by signal to noise ratio, right? Look at this point. What is this? This is signal to noise ratio at the sampling point. Means the point where you take the sample, what is the signal to noise ratio at that point? So this is the meaning. What is this? Look at this. This is time variation of zero crossing, or you may say measure of jitter. Jitter we will discuss in next slide. And what is this? And okay, what is this? This slope. This is a slope indicates sensitivity to timing error. The smaller the better, right? Small. So we want that slope should be small. And what is this? This is best time to sample. Okay, best time to sample. Yani take the decision. whether 1 or 0, right? So we want eye opening rather than eye close to get the best signal to noise ratio, right? So just focus on jitter. Jitter is the short-term variation of the instant of digital signals from its ideal position, which may lead to data error. Actually, jitter is the variation of the in the digital signals. When there is a variations, you can't you can't take the sample at the time when the digital signal is fluctuating or some variations, because this may affect the result. This may affect the output, right? So that is, the jitter is the short-term variation of the instant of digital signal from its ideal position, which may lead to data error, right? So when the effect of ISI increases, traces from the upper portion to the lower portion of the eye opening increasing, and the eye gets completely closed. So when you see that the eye is closed, that means then ISI effect is more, right? So if ISI is very high, the pattern look like eye gets completely closed, because the distance between these two, what do you say, two vertical lines are small, right? So in that condition, this eye considered to be closed. So closed eye means ISI is very high. Now discuss, there are some points. An eye pattern provides the following information about a particular system. Number one, actual eye patterns are used to estimate the bit error rate and the signal to noise ratio. So by using this eye pattern, we can estimate the how much the bit error rate in the signal and the signal to noise ratio also. Actually, try to understand this eye pattern. It's just like that. By seeing the signal, by just seeing the signal, we can predict many things about the signals. Like when you go to the when you are not feeling well, and when you go to the doctor, but by just seeing the eyes, your mouth, your face, predict the type of disease that you have, and take the steps, and write the medicine according to that. In the same way, when digital communication engineer seeing the eye pattern, then by just seeing the eye pattern, engineer can estimate the bit error rate and signal to noise ratio, right? Understand? So there are certain meaning of eye pattern. The width of the eye opening defines the time interval over which the received wave can be sampled without error from ISI. Next, the instant of time when the eye opening is wide will be preferred time for sampling. This is ideal time for sampling when the eye look wider or in a position of open, right? The rate of the closure of the eye according to sampling time determines how sensitive the system is to the timing error. And the height of the eye opening at a specified sampling time defines the margin over noise. So hence the interpretation of eye pattern is an important consideration, right? So just this eye pattern is helpful for the engineer, digital communication engineers, just by seeing the pattern of the signal that we call as the eye pattern, because the signal is, the pattern is look like, is resemble with the eye, human eye. That's why we call it as a eye pattern. So just by seeing the eye, this particular pattern, we can, the engineer, the digital communication engineer can predict many things. The two important things are signal to noise ratio and the bit error rate in the signal. Okay, so thank you very much.